Assalamu alaikum warahmatullah. This is chapter 7, in which I would like to cover the expressions and assignment statements. I will try to record 2 videos to cover this chapter so that the videos will not actually be very long and heavy for upload. This chapter was not included in the syllabus, but it should be in the syllabus. Now I actually ask you to follow the weeks to see the topics posted instead of going back to the syllabus, because there is a little bit change in the topics that we cover for the rest of this term. So every week the PowerPoint uploaded and the videos uploaded are those topics that we are going to focus on. Expressions and assignment statements will be covered in subtopics: arithmetic expressions, then overloaded operators, in which it's going to be the focus of this today's video. Then we have type conversions and relational and Boolean expressions, then short circuit evaluation, assignment statements, and mixed mode assignment. Let us first define what expressions are. So what is expressions? Expressions are the fundamental means of specifying computations in programming language. It is a fundamental means of specifying computation in a programming language. That means mathematical equations, formulas, all these include expressions. For example, if I have an equation like this: y equal c plus 5 divided by x. It has 2 parts: the part that is before the equal sign and the part after the equal sign. So here, this part, it is called what? If this is an operator, and this is a variable, and this is an operand, and this is an operand, this is an operator, this is an operand or a value that has given a value. 5 is a value, but x might be given a value later. It is a variable now. So, but what is this on the right hand side? This is an expression. So we can call expression is a building block of an equation. So in programming language, expressions and the fundamental piece that the mathematical computation depends on. So to understand expression evaluation, we need to be familiar with the order of operators and operand evaluation. So here in this example, we have operators and we have operands. This plus this division and this equal, which is an assignment statement, assignment operator. So we call it operator because it is an assignment operator. This is a plus operator. This is a division operator. So what are y, c, 5, and x? They are operands. But now to understand the expression, we have to understand the order in which these work. So the most important thing is to try to evaluate an expression based on the what we call operator precedence. So arithmetic evaluation was one of the motivations for development of the first programming languages. We have to use arithmetic evaluation and expressions that consist of operators, operands, parentheses, and function calls. So this one has all these examples except the function calls, which can give an example later. But parentheses, these are the parentheses. Operands, this blue colored letters are operands. Operators are the red ones: the plus sign, the equal sign, the minus here, the division. All them we call them operators. These are mathematical operators. Of course, we have other operators like bitwise logical operators, which we will cover later, like relational operators and so on. Uh, so there are some design issues when we talk about arithmetic expressions. First, we need to know about the precedence rules in different programming languages, because not all programming languages follow the same precedence rules. Also, the associativity rules between operands. So which operand is evaluated before the other operand. But when we talk about operator precedence, we talk about which operator is evaluated before another operator, and so forth. Order of operand evaluation, also evaluation of operands, which are the components of the expression. How are they also evaluated? And also we need to look for the side effects and shortcomings of the operands evaluation. Then also we need to think about what we call operator overloading. Operator overloading means when the operator is used for more than one purpose. Also, type mixing in expressions. Type mixing in expressions, like you mix an integer plus a double, and then you add a float here, for example. The first one could be considered as a float, this one could be considered as double, and so forth. What we call mixing expressions, when we mix expressions together also, and mix different types. Type mixing means the data type mixing in expressions. These are all different design issues that we will try to answer when we talk about arithmetic expressions. First, let us talk about operators in arithmetic expressions, which we can divide into three different: unary operator, binary, and ternary. Unary, when we have one operand, has one operand, like this one, for example, I. So can we have one operand with one operator? Yes, like this, plus plus I, or I minus minus. These are examples because in which you can think about the first one as an increment and the second one as a decrement. It could be before or after, but this is not the deal. The deal here is when you have plus plus, we consider it as a unary operator. Minus minus, we consider it as a unary operator, and we have one operand, which is one operand, like I. So we don't have another operand, which this one can be expressed as I equal I plus 1, or this can be expressed as I equal I minus 1. So a unary operator when you have one operand with the operator. So this is an example. A binary operator, on the other hand, has two operands, like this, y and x. So plus, just plus, we call it binary. All right. Minus also could be binary because it actually has two operands, which is y and x. Also, if you use division, if you use multiplication, all these are examples of binary operator. Ternary operator has three operands. In this example, we have three operands, which is here have, for example, m, n1, n2. In this example, this is called the conditional test. We will have an example later. We'll talk about conditional test, but this is an example of a ternary operator in which we have three different operands. We use usually this question mark to separate the conditions. So we have one condition, but we have two resultants, either n1 or n2, as we will see in a minute in one of the examples. When we talk about operator precedence rules, the operator precedence rule for expression define the order in which adjacent operators of different precedence levels are evaluated. Adjacent means back to back, neighbors neighboring operator, يعني the operator which comes after this, after this, after this, after this immediately. How is it going to be evaluated? What is the rule for that? So according to the typical precedence levels for many programming language, we evaluate parentheses first. So if you have something in between the parentheses, like for example x plus 5, for example, in any expression, so this one will be expressed first or evaluated first. Then if you have a unary operator in the same expression, then we also evaluate it second. And if we have an expression that contains parentheses and that contains like unary operators, then the precedence or priority will be given to the parentheses, then to the plus plus or minus minus, depend on which one comes before the other. And if plus plus comes before minus minus, then it is going to be evaluated before it. And if minus minus comes before plus plus, then it's going to be evaluated before it. So it is actually from what? From left to right. This asterisk star star, it is only applicable in one of the scripting languages, I think Python. But what does it mean? It means simply the right hand side is raised to the one in the left hand side. So I'm going to give an example also to explain this one, but not many programming languages support this operator. Then if we have this one, then we have it after the unary operator. If we don't have it, in the same expression we have multiplication and division, then they will be evaluated. Whichever comes first, evaluated first. Yani if multiplication comes before division, then it is going to be evaluated before it, and so forth also. And the last one going to be evaluated in the operator precedence is plus and minus, also from left to right. Whichever comes first is going to be evaluated first. So here I can actually give an example. If you have, for example, y equal x plus f divided by I multiplied by 6, and then minus 3 divided by g, and then we have this one between parentheses. So what is going to be evaluated first? This parenthesis is going to be evaluated first. All right. Then we don't have this unary operator, and we don't have this exponent operator, but we have others. We have a plus, we have a division, we have multiplication. So after we do this one, number 1, let me give it a different color. Then we do what? We do this one as number 2, because it comes here in the list, but division comes before multiplication. So actually what we do, we divide f divided by I. Then we multiply by what? Multiply by 6, because it is going to be from left to right, right? So then these are evaluated. This will be evaluated. What is left for us is a plus and minus. So this, there is no any difference in evaluating it, but usually it is recommended that you go from left to right, like that. Then I mean you add x and then you subtract the resultant of this parenthesis. So the operator associativity rule is also a little bit similar to this rule of the precedence. But this, for expression evaluation, it defines the order in which adjacent operators with the same precedence level are evaluated. Yani what does that mean? It means if we have the same precedence level, yani we have multiplication, division, multiplication, division. So we don't have any plus or minus. So they are the same level. So how do we evaluate it? We evaluate it from what? From left to right. From left to right, except the double star, which is, I did talk about it earlier, and I said I'm going to give you an example. This is the example I'm going to show you right now for this one. But anyway, let me go back to my expression here. This expression, c multiplied by x divided by y multiplied by f divided by g, which one is going to be evaluated? It is from left to right, from left to right. So you multiply this one by this one. Then the result of these two will be divided by y. Then the result of these three will be multiplied by f. Then the result of this will be divided the result of this will be multiplied by f, right? Then the result of this will be divided by g. So it is from left to right, step by step. This is what we call operator associativity rule for expression evaluation. So for example, we have here this this operator star star, in which we have x star star y. We don't have a lot of programming languages supported, but usually I think Fortran, actually Fortran supports it, and we can use it in Fortran different versions. What does that mean? It means here y raised to the power x, yani it is the other way around. It is from right to left. Y raised to the power x. In this case, yani 15 multiplied by 15 multiplied by 15 multiplied y raised to the power x. You multiply y, which is y 15. Yani here you can replace only this one by 4, and this replace it by 15. So what does that mean? It means 15 raised to the power 4. Yani 15 multiplied by 15 multiplied by 15. Let me see this here in this example. 15 multiplied by 15 multiplied by 15 multiplied by 15. So it's going to give you 50,625, which is this number. So this is an operator that has an exception, which is going to be from right to left, from right to left. APL also is different. All operators in APL, by the way, APL has all operators have equal precedence. That means yani, there is no specific operator has precedence rule, and also all operator associativity rule is from right to left. You evaluate them from right to left, not the other way around. But everything here can be overridden with a parenthesis. Yani precedency and associativity can be replaced by can be overridden with parentheses. What does that mean? It means can be overridden by this. Like if I put this one like that, so I actually now operator associativity rule will be different, which is this one will be now evaluated first. Then you start from left to right, and then you come here. That is already evaluated. Then you divide by this resultant, and then you divide by g. So that's what they mean by the overriding of precedence and associativity rule when you actually use parentheses. In Ruby, all arithmetic, relational, and assignment operators, as well as array indexing, shift, and bitwise logic operators like and or and not, all these are implemented as methods. So they are actually Ruby implement them as methods. So you don't do a lot of job as a developer or a programmer. It is already actually implemented in these methods. So when you use the method, you already implemented this associativity and precedence. Also, this operator can be overridden by application programs. يعني if you impose some application program in Ruby, which is embedded programs, you can override the Ruby's default methods implementation of the operators associativity, precedency, and operance associativity. In Scheme and Common Lisp, all operations called subprograms or functions, and these programs can be coded as functions and can be used to replace these arithmetic operators and operands when they are put together in expressions. And also I told you about that statements earlier when I was talking about this ternary operator. I said I'm going to give you an example. This ternary operator, in which we have 3 operands, can be also thought of a conditional expression, which is conditional expression. It's an expression that is replacing an if statement. Yani, look at this if statement. If count equals 0, equal 0, average is equal to 0, else average equal to this. So this one can be expressed in only one statement, in which we have used like 3 different operands. What are the 3 different operands here? Average, count, sum. There are 3 different operands, and we have operators. So we use this conditional operator to do it. Like this example, for example. So I have, for example, this statement, which is I have n1 equal 5, n2 equal 10, and I have max. I can use if statement here if n1 is greater than n2. This is in a C++ statement. Then C out maximum is our assign max equal what? Equal n1, right? Else max equal n2. Then you display what? Display the maximum value. Since I have n2 here is a maximum value, what happens? This program will display what? This program will display the value 10. Okay, let me check it. There it is. Maximum is 10. Alright, so when you use if statement like that, you can replace all this with this conditional operator, which is you use 3 different operands, max, n1 and n2, with a question mark, in which you are saying assign one of these to max, either this one, either the result of this one, or the result of this one. That means it says this is a condition, n1 is greater than n2. If this is true, you are asking a question. If this is true, this question means if this is true, is n1 greater than n2? And then you're asking a question, right? If it is correct, if it is true, then n1 is maximum. Otherwise, this column means otherwise. Otherwise, n2 is a maximum. In this example, I have n1 is not the maximum, so it's going to be n2, which is 10. So this one will replace also this program. So if I have, for example, here 4 and this is 6, so this one will give me what? Will give me 6, which is n1 in this example. Okay, so what I mean here, this expression, this example for C and C++, conditional expression can also be used as a ternary operator. Okay, arithmetic expression, operand evaluation order. So how to evaluate, evaluate the order. First, for the variables, you need to fetch the value from the memory. Yani the computer program will look for the value of the variable from the memory. Regarding the constants, sometimes this search from the memory is machine language instruction. So sometimes there is a built-in constants, sometimes built-in constants. Sometimes these variables assigned, that means they are residing in the memory in a specific location. So the computer program, once it is executed, it is going to be assigning or storing these variables in their locations, or the constants, if they are a specific constant that are already built-in constants, for example, or parenthesized expressions, and which is the expression that has in parentheses, in which evaluation all operands and operators will be evaluated first, and we have known from the order of evaluation already, as we have explained it earlier. But the most interesting case, I said, when you have operands inside a function call. And if you have a function and you have operands inside the function call, then the rule here, it depends from one language to another. But in C, C++, Java, so the first parameter is going to be used for the first argument, and the second argument is going to be used for the second parameter. And for example, if you have, for example, here you have for example, int x equal 7 and y equal 8, then in this example, what you use is the value for x is going to be here. So for example, if you replace this one y and this one x, so the same thing. So here 8 will be used for x and 7 will be used for y. So it depends on their declaration or parameter passing. So if they are passed from one function to another parameters, then will be used as in the order they have been put inside the function call. For the function side effects, when a function changes two-way parameter or non-local variables. This is example. For example, a function is using a parameter called x. But here, look at this function call. The function call is x plus function, and then they're using x inside that function call. So if function changes x, then there is a side effects. This can cause a lot of problems in the calculation of the program. Sometimes it can produce two different inputs. It depends on if you are using a function that uses pass by value or pass by memory address. Because if it is passing by value, then the value that will be produced is going to be different from the value that will be displayed when you are passing that variable by address, which is the memory location, the place where the variable is residing in the memory. So when a function actually changing the value of x, then there is what we call functional side effects, which is, that means there is some issues will be raised, which is says some problems. Actually, these problems can be changed, or can be minimized, or can be removed, or can be solved by different development processing in the language. Also, there is some problems with functional side effects, like when a function referenced in an expression alters or change another operand of the expression, like this example. For example, here, this pass is passed by address. When you use in C++, for example, the value of a here is not going to be 10, because this 10 is actually going to reside in the memory as a value. So if this function changes the value of a before being called in this location, then the value residing in the memory location will not be the same as the value here as 10. Specifically, that you are using the a here twice in this expression, which is a a, which is 10 in this case, plus function, and then between two parentheses you are calling this function with the memory location of a, which is the memory address of a. In this case, it depends on the program. If the program changes the value of a, and then the value of a residing in that memory location will be different from this value, will be different from 10. So this one is not going to give you 20, it's going to give you a different thing. It's not going to give you 20, yani it's not going to give you 10 plus 10. No, it's going to give you a different value. It depends on which value that has been changed in that location. Two possible solutions to this problem, which is, first, you can write a language definition to disallow functional side effects. The language definition itself, which is written to create like header files, to create constant definition, stuff like that, that actually freezes the two-way parameter passing. Like don't use two-way parameters in a function, or don't use non-local variable in function, like global variable, for example, which the value is going to be available for all different programs or functions in the same program. Although this is going to work, but it is inflexible and is going to be using all different variables, like global variables, not local variables, global variables, or parameter passing, which is sometimes it leads to what is called writability and readability issues. Also, in some programs, I would say there is some referential transparency. Transparency means when a program has functional referential transparency, then any two expressions in the same program will be having the same value, can be substituted for any value. Look at this example. For example, here I have this expression, which is result 1 equal function 1 plus b, here like this, divided by function 1 minus c. Then they are using temp as a variable to be equal fun a, yani they can replace this fun a here and this fun a here with a newly declared variable called temp. So when you have result 2 will be equal temp, which is this one, which is function a, which is this one, plus b, same like this, except they are actually replacing function 1 with temp, and here replacing function a with temp. In this case, if function 1 has no side effect, yani the can mappify side effects, that means result 1 equal to result 2. How do you know that there is no side effects? When you have this kind of example where you have a variable declared to store the output of one function, then you use that variable to replace that function in another expression. Then if the result 1 equal result 2, then there is no side effects. Otherwise, referential transparency is violated. So we can say that referential transparency existing if any two expressions in the same program have the same value, can be substituted for one another anywhere in the program without affecting the result of the program. So the advantage of this one is semantics of program. That means it's going to be easier for programmers to understand it if it has referential transparency, شفافية يعني, what is called in Arabic. So functions cannot have state which would be stored in local variables. This is one of the transparent referential attributes, or it's called properties. And also, if a function uses an outside value like global variables, for example, it must be a constant or it could be a global variable. So the value of a function depends only on its parameter. So it could be a parameter coming from a different function, or it could be a global variable that declared outside the program. In this case also there is transparent. That means semantic. The meaning of the program is much easier. The resultant of the program is much easier than the program that has all local variables that can be declared inside some programs and cannot be expressed in different programs as variables, because the names used in one program can be used in a different in another program. The same variable that is declared as a local variable in one program can be used in another program with the same name, a different value, same name and different value. In this case, there is what is called referential transparency or not transparency, or difficulty in readability of the program, because the variable can be used in the same program in different functions with the same name, and that will create some sort of confusion. And this will also will lead to what is called overloading, variable overloading. We have overloaded operators, we have overloaded functions, and we have overloaded variables. This slide talks about overloaded operators. What is overloaded operators? The use of an operator for more than one purpose. Yani, for example, you have in this Java script, for example, you have, for example, to add plus and plus. So use plus here has a different meaning from plus here, right? We have minus. We'd like to add this statement. This statement is to display this minus plus plus, yani minus and plus. So instead of minus and plus, I would use plus here, for example. So plus here is different from plus here. And also, if you have plus between parentheses, is different from plus without parentheses. Sometimes use of operator, same operator twice with different purposes is called overloaded operators. Also, sometimes you are using this one, for example, star in C and C++, which have different meanings. And star in C and C++, this star we use it for pointers like this. For example, name equal like, for example, array, for example, Joe, Jim, and so on. And so on, for example, Ken. I would like to store some arrays in the memory location under what is called pointers. We use a star here. So this star is different for what? From a different star we use, which is multiplication. So if we have num, for example, num equal y multiplied by t divided by 6, for example. So this y here is different from this. This y here is multiplication. You multiply y by t. But this one means it is pointing to the location where this number is residing in the memory location. In a nutshell, I would say that this usage of operator twice in an expression with different purposes is called overloaded operators. Such operator can be a problem, specifically in readability may suffer even when operators make sense, and even if the operator makes sense, sometimes we have these potential problems. It could be also a means for what's called avoiding method calling and using it as shortcut methods and so forth, but unfortunately it might create some confusion and make some readability issues for this. This topic here, I would start next video from type conversion, so I would actually stop this chapter in this slide number 17. Thank you so much.